This is part 11, and today I'm going to discuss about LogMAR metrics and ETDRS chart definitely. So let's move on forward. We know LogMAR is far superior than Snellen chart. That's why in all the research, in clinical trial especially, we definitely wanted to use LogMAR chart. So LogMAR chart, it's a very important point. Why LogMAR chart is so superior? Because of its logarithmic progression of the letter size, and each letter counts, because it matters that whenever these four lines is read and other cannot be read by patient, then we count only four letters, uh, and we give visual acuity. So each letters count 0.02 logmar into 5, which is 0.1 logmar. That's why you see 1 logmar, 0.9, and each time it reduces by 0.1 logmar. And the beauty here, see, whenever it comes to 0, it's 6. Then it again goes like 0.1, 0.2 minus, and minus 0.3, isn't it? So in this picture it's up to 6. So this is another thing. And another thing, just you understand, every third letter from this row, first, second, and third, this is exactly half of this letter. Okay, first, second, and third, this is exactly half of this. Okay, first, second, and third, this is isn't it, this is exactly half of this. So can you see this visual acuity? In case of 2020, 20 by 100, 20 by 100, 20 by 50, 20 by 50, 20 by 25. So in every third row it's get half, or every third it becomes twice, or from lower to higher or higher to lower. It's very important whenever we try to understand another point. Okay, so can you see this third point means from 1 you minus 0.3, from 0.7 you minus 0.3, isn't it? 0.4, from 0.4 you minus 0.3, 0.1, exactly half and half. That matters, that 0.3 matters. Okay, I'll tell you why it matters later on. Okay, so each letter counts. One more letter read means logmar decreases by 0.02. Why it decreases? Because logmar 1 is worse and logmar 0 is better, and logmar minus 0.3 is far better, isn't it? That's why it decreases as you read more and more later. The logmar decreases from 1 or 1.1, or I'll tell you later. Okay, so one letter missed, then logmar increases. It's central important to understand. Logmar functions oppositely. As the vision gets better, the logmar gets decreases, isn't it? From 1 to decreases. As visual acuity is worse, logmar increases. Okay, so one more line, which means 5 in 1, 0.02 means 0.02 into 5 is equal to 0.1, isn't it? So one more line read means decrease by 0.1. That's why it's 1, 0.9, 0.8, 0.7, 0.6, 0.5. Isn't it? It's simple. Okay. See, this is the tricky, and most of the students get failed here. Okay. So one thing I want to mention, just think about this line. What if I just read this line? Is it 1? Is it 0.98? The most of the student got wrong there. If you read all the 5, then it's 1. Yes, it's tricky. If you read all the letter from the first line, then it's 1. If it is not, then remember this formula. It's very important. Logmar visual acuity is 1.1 minus 0.0 into total letter rates. Let's take an example. Okay, let's take an example. Someone read these two letters, means 1.1 minus 0.02 into 2. It means 1.06 at that time. It's crucial. We have to understand this concept. Okay, it's crucial. Otherwise you can also say, if someone read these two, then someone cannot read these three, isn't it? Then you can do one trick. One plus 0.02 into 3, because this is 1. Whenever you plus, it means you adding whichever letter is not red, because see, because you add increase whenever missed letter is count, whenever you decrease whenever red letter is count, whenever red letter is red count. Okay, that's the main trick. You cannot use 1 minus something, you cannot use that. Okay, many of my students in past, they use always like this. For example, they read 2, it means 1 minus 0.02 into 1 minus 0.02 into 2, so answer is 0.96. No, that's not the answer. Okay, if you are doing this, you are using this value, always add what, the letters not read, finished game. But this is the game finishing point. See, let's take an example. Okay, let's take an example. Someone read this line all and above this. Okay, someone read this. What do? You do this 0.8 plus not read 4 into 0.02, which means 0.88. Now game finished. Okay, now game finished. But you can do also one thing which is very, I think I love that. Okay, just see. Count 5, 10 and 11. 11 letters are red. Just do this. 1.10 minus 2, 0.02 into 11, which means 1.1 minus 11, 0.22, which means eventually 0.88, isn't it? So this is also best idea to do. But remember one thing, whenever you urge to do with this lines means I will use this, then always add, not subtract. Always try to add. Otherwise this formula you use. If you want to subtract, then use this formula. Okay, it's quite another thing. But I love to do add, not subtracting. Or I love to do this thing, which is very helpful. So just remember this thing. Okay, just remember this thing. Okay, let's take an example. This chart is made for 4 meters, and some low vision patient cannot read this letter also. Then what you'll do, you half the distance chart, you put chart at now 2 meter distance. And as we know, what do we know, that as we half the distance, because see, whenever third letter, it becomes half. That's why, see, for example, you half the distance, you put the chart there, and chart is now he can read these 3 letters. It means now whatever it comes, you will add 0.3, finished. Because in 0.3 means you'll double the angular size, isn't it? In every 0.3 you double that. So this means 200, which means 1.04 plus 0.3, which means 1.34 is logmar value final. First you half the distance, which means you have to add 0.3. Why 0.3? Because every 0.3 distance angle size is halved now, which means we add the 0.3. It's very simple. Okay, just remember this thing. Whenever patient cannot read on the first line, then you will half the distance. Why halving? Because by doing half, we can add 0.3 to visual acuity chart, which means same thing. Okay, finally, let's discuss what are the advantages of ETDRS or LogMAR over Snellen Chart. It's very important. We have discussed the Snellen Chart's fallacies, and at that time I already told you that all the fallacies are covered by, at least almost all fallacies are covered by Snellen's ETDRS or LogMAR chart. Okay, fine. So equal letter spacing, which is definitely not in the case of Snellen's slit. In case of ETDRS chart, every letters are equally spaced. See, I have forgot to tell you one important thing. Sorry. So the space between these two letters is always equivalent to the size of this letter. Okay, it's very important. Remember, space between the, no matter what, between R and C, between H and S, it's equal of these letters. Okay, the space, vertical space, horizontal space is equals to this. The vertical space is always equal to this lower letter. Okay, this letter, this space. Suppose space between Z and N is equal to size of n. Space between D and Z is equal to size of Z. Space between Z and C equal to size of C. Space between C and O equals to the size of O. But space between R and S is equal to the letter size of R or letter size of S or letter size of O or letter size of D. I think I'm clear now. Okay, that's very important. Sorry, I forgot that. Okay, letter spacing are very equal. No matter what in horizontally, no matter what vertically, it's ruled, governed. Okay, so and another thing, logarithmic progression of the letter set, which is fantastic for the calculation. Okay, it's very fantastic for the calculation. Unlike Snellen's chart, non-consistent is because in Snellen's first letter is always like single, second letter there are two, third letter, and as letters increases, crowding. But that's not the case with ETDRS and LogMAR chart. Okay, so second, standardized number per letter, there is always 5 finished. But in case of Snellen's, there is 1 for the first, 2 for the second, 3 for the third, and I don't know, 7 or 8 for the last. It's very irregular. But in case of ETDRS or LogMAR, it's always 5 finished. Geometrical progression, that's fantastic point. That's why we can half the distance, isn't it? Because whenever it progresses, first line, second line, third line, fourth line, the first line and fourth line is exactly half. Fourth line, fifth line, sixth line, seventh line, exactly half to upper, or you can say double from lower to upper. Which geometrical progression is fantastic. As a LogMAR, you have to write it in your answer sheet. Okay. So consistent letter crowding, it's not increasing like Snellen's. There is always consistent letter crowding. As I have said, horizontally equal size of the letter, vertically equal size to the lower letter, as I have already told you. More precise in measurement because it allows small changes in the vision because every letter counts. Every letter counts. See, scoring flexibility because 0.02 each letters. So we don't have to worry about anything because one letter red means red and it counts. One letter means 0.02 reduction. One letter on red, 0.02 increase in logmar value, isn't it? Okay, so improve repeatability, it's always there. So standard variability between the testing is its repeatability is very high. In case of low vision, no question, ETDRS and logmar is best and standard. Now this is the case, widely accepted in research. In research, whenever we have to put mathematical value of visual acuity, it's very important. And for the calculation, it's very precise, very helpful, and I don't know what to say. In research, ETDRS is gold standard. Just remember, it's a gold standard in clinical, especially in clinical trials. My goodness, it's gold standard. Okay, so ETDRS, remember 0.02 each letter, 0.1 letter, logarithmic progression. Remember spacing between two letters equals to the size, spacing between vertical lower letter size. Remember in every third line is half. Remember halving distance for if visual acuity is poor, then we will add in visual acuity whatever it comes, 0.9 plus 0.3, and the logic of 0.3 is size is half or double, whatever from lower to upper, double from upper to lower, half. So these are the concepts. Okay, so logmar, you have to understand a lot of things about. Again, my favorite book of all time, my favorite professor of time, Professor Dr. George SML is. Okay, bis dann, tschüss.